Welcome back, everyone. So for today's lesson, we're going to look at completing the square. Now, completing the square is a process that allows you to convert the quadratic function in the form of ax squared plus bx plus c into what we call a vertex form. Now, why do we want to do that? Why do we want to convert into a vertex form? And the reason is really because from the vertex form, right, we will be able to then identify the coordinates of the vertex. And vertex is really what we call it a turning point or a stationary point. Now, let's look at the first example. So, we're going to look at y equals x squared minus 4x minus 5, and notice that we can complete the square first by removing 1x each from the x squared term and the 4x. And then we're going to halve the 4 to get you x minus 2, and then we put the square on the outside. Now, notice that when you expand that, you actually get x squared minus 4x plus 4, and that plus 4 doesn't really exist in the original equation. So we're going to minus 2 squared to effectively minus the plus 4, and then we carry on with the minus 5. So as such, you see, we have done the process of completing the square, and turns out that our turning point, the x coordinate, will be whatever that makes the bracket x minus 2 squared 0, and that x is 2. And the y coordinate for the vertex will be minus 9, whatever the value is at the back of the equation. All right? So the turning point here is 2, minus 9. Now, we can identify that this is actually a positive parabola, or in short, we call it a U-shaped parabola. So the turning point here will be all the way at the bottom, and that's why we say it is 2, minus 9. All right, let's look at the next example, example 2. Now, the difference with the first one and the second one is that the second one has a coefficient in front of the x squared value, which in this case is 2. So what we're going to do first, we're going to just rewrite the equation, and we will need to factorize 2 from the whole entire equation. Yep, so when I factorize it, now it becomes x squared minus 4x minus 1.5. All right, so that's what's left when I factor out 2. Now, from here, you can just go ahead and complete the square as per usual. So we're going to remove 1x each and half the 4. So we get 2 minus 2, yep, square good. And from here, we're going to look at removing the extra term when we expand x minus 2 square, and that will be actually minus 2 square. And then we will proceed on to bring down the minus 1.5 from previous working. Simplify the back constant term, and that will be like minus 4 minus 1.5. So that's minus 5.5. And now this is a very important step. We need to then multiply the 2 that we factored out earlier on back inside the equation. So what we end up having is 2 bracket x minus 2 squared minus 11. So similar to the previous example, this is a U-shaped parabola because the coefficient of x squared is 2, and that's positive. So we do expect our turning point to be 2, minus 11. Again, why is it 2? It's because whatever that makes this bracket 0, that will be the x coordinate of the vertex, and the y will be whatever's at the back. In this case, it's negative 11. All right, so I hope these two examples are clear, right? How do you complete the square? And now we're going to move on to example 3. And example 3 is a bit tricky because the coefficient in front of the x squared is actually negative. So we are going to first factorize the negative 1 out from the entire equation. Kind of similar to example 2. All right, so we factor out negative 1. And from then onwards, it will be very similar to example 2. Yep, so I managed to factorize negative from it. Now that I have that, I will complete the square inside that bracket. Yeah, I should use a bigger bracket. Yep, so x minus, or no, x plus 1.5, because I'm going to half 3, right? And then put a square, and then extra term minus 1.5 square, and minus 4, I carry on from the previous working. I clean that up a bit. Yep, so I got minus 6.25. Now, do not forget, I have to multiply the negative one back into the inside of the bracket. Okay, so I will proceed on to multiply through. So you have negative bracket x plus 1.5 square plus 6.25, which then indicates to me where is my vertex. So since this is a negative x square, it will be a maximum parabola. So it will be a maximum point here. So my turning point or my vertex is negative 1.5 and 6.25. Why negative 1.5? Because that makes the bracket 0, right? Minus 1.5 plus 1.5 is 0. So that's why my x vertex is negative 1.5. And I mean 6.25, you know, is whatever's at the back. So we just copy and paste. All right, so that's example 3. And we want to look at the negative. Make sure you have the negative in front, and notice that the negative don't really affect the turning point, right? The negative just really tells us that it is a maximum curve. All right, let's look at example 4. We are going to actually factor out negative 2, because example 4 is kind of the same like example 3, but we're going to factor out negative 2 instead. Alright, so that is what I have back in the bracket once I factor out negative 2. So x squared plus x minus 4. And I'm going to complete the square. So remove one x each and half the x term, which is half now. Put a square. Alright, so the extra term I want to remove will be half square. Alright, and minus 4 I'll copy and paste as from previous working. Clean that up a bit. So that will be minus 4 and 1/4. Yeah, 4 and 1/4. Now, don't forget, you have to multiply the negative 2 back into the bracket. Yep, and also to the minus 1 and 1/4. Let me calculate that. I think that is about 8.5. Yeah. All right, good. So what's my vertex? It is a maximum because it's a negative 2x squared. Yeah. And the vertex, of course, whatever makes the bracket 0, in this case will be negative half. And my y vertex will be 8.5. What's at the back? Okay. All right. So I hope this 4 example has been useful to help you to understand the process of completing the square. And if you have any questions, feel free to ask. All right, I will see you in the next one. Cheers.